I'm Rod O'Shea. I manage the IoT business for Intel, Europe, Middle East and Africa. Just before I start on the content, just a kind of comment on Intel's continued kind of innovation. I assume everyone here has heard of Moore's Law? Most people? Who knows how old Moore's Law is? Does anyone know? 50 years old, congratulations. So Gordon Moore postulated this law 50 years ago that said you can basically double the capability transistors on an integrated circuit or kind of half the cost in the same period. And just to give you kind of just a thought at the moment, you know, we've heard some talk today about increase in technology and innovation and ability to do more. From that initial microprocessor, the performance of microprocessing has gone up 3,500 times. The efficiency has reduced by a factor of 90,000, and the cost has gone down by a factor of 60,000. So if you just think about that in a relatively short period of time, 50 years, and just think about how we move the next 50 years ahead. And just to give you kind of one data point on that, if you extrapolated Moore's Law to the oil and gas industry, if the day you were born, you put 4 litres of gas in your car or truck, that would last your whole life if you lived to 100 years. So it just gives you kind of an indication of how rapidly technology is changing. So I'm actually here to talk about the Internet of Things. Intel defines the Internet of Things as devices that connect via typically gateways into a cloud that generate data, and that data can be analyzed to deliver valuable insights. You've heard a lot today about it's all about the business model, it's all about the data, and this is the way that the Internet of Things is going to drive. And those things are moving very quickly. You saw in the video, if you add up everything that's connected today, phones, PCs, TVs, there's about 15 billion connected today, and there'll be about 50 billion by 2020. So 35 billion new things becoming connected in the next 5 years. And that's a huge opportunity for everyone in this room, both in terms of putting those systems together, but then really getting the business value from those deployments. And we'll talk about some examples of that. And I will come back to this schematic a bit later on and try and flesh out some of the details of it. So first of all, unstoppable trends going on out there, new generations being born connected, the usage model of technology with youngsters, the new generation is happening fast. And you know, just again, food for thought. I remember we were all talking about kind of generation 2000 and all these kind of new youngsters coming into the world in 2000. The first generation 2000 kids are entering the workplace next year. Really, in kind of 15, 16, you're going to start seeing that next generation of people entering the workforce. You saw some great data this morning on global demographics. 10 billion people by 2050 from about 7.5 billion now. 2.5 billion new people in the next 35 years. And actually, what's interesting is when you aggregate that all out, that's all going to happen in urban areas, urbanization. So you'll end up with 7 billion people in urban environments by 2050. My own home city of London is adding 2,000 people a week at the moment, which is basically 1 million people a decade. And just the requirements there for all the city infrastructure is massive. We're seeing the rise of megacities. And there are some big challenges there. You know, water, energy, we'll talk more about that. But behind all this, data is the new currency. We introduced the concept last year of SMAC, which is social, mobile, analytic, and clouds. So we're seeing a mass socialization of information. By the way, interesting data point, you go back a year, half of Fortune 500 CEOs weren't active in social networks. They are becoming more so now. Social communication defines the way communities work, defines the way businesses work. You think about the way Intel manages our own public relations and brand is very different in a world of social networks. So that's created a massive change. Mobility, information everywhere, but then that needs to be linked to everything can generate some data. How do you add analytics to that data? What do you do with it? And when people think about the Internet of Things, they think about PCs, laptops, robotics, programmable logic controllers, actually you're adding intelligence to the infrastructure. So the doorway here is just a very simple static thing, but you can add intelligence to that doorway. For example, a people counter tells you how many people are coming out in the room. That's starting to generate information you can do something useful with. And so this whole idea of taking the existing infrastructure and by the magic of IP adding value to it is quite profound, and it will change everything. You've heard a lot today about the convergence of IT and OT. It does change everything. It's a strategic inflection point. I don't have time to go through all the kind of details of this in a pretty short presentation, but a couple of things to consider. First of all, I think many of the speakers today have touched on security. Security is absolutely profound to delivering the Internet of Things, and it has to be considered at the start. It can't be considered as an afterthought. You need to have an environment where you can create applications and deploy applications in a simple way. You think about the PC. You build an application, you put it on the PC, it just runs. You expect it to run. This is the framework we have to build for the Internet of Things to unleash all the innovation we've talked about earlier. And the conversation I have frequently with startups, big businesses, governments, where do I start? Where do I really go for the most impact? So let's talk about security. You've heard today a huge number of potential deployments for the Internet of Things. We have live examples in each of these areas, and I could talk about them all in great detail. But the interesting thing is that Internet of Things is starting to be deployed in these areas, but you have to do it with hardened devices, secure communications. Then you need to analyze and monitor that complexity while keeping the whole infrastructure secure. So Intel's philosophy, Intel has over 20 security capabilities built into our silicon software layer around silicon to enable us to harden the internet. And just to give you kind of just a simple analogy for those of you that aren't kind of immersed in security, sometimes you're expecting someone. Something gets provisioned on the network. Richard introduced me. I know roughly what Richard looks like. He introduced me. I was expecting him to introduce me. He was actually, he looked kind of like I would expect Richard to look, and he did the things I would expect Richard to do. So I managed that security in a very specific way. Just as if a printer jumps up and starts printing, that's probably what you expect it to do. So you have to start from this root of trust saying, I know what something is and I know what it's going to do. If somebody turned up that wasn't Richard and dressed as a clown, I might start thinking, well, that's quite strange. Or if Richard introduced me and started doing cartwheels or any kind of other strange activity, I might think, well, there's something not quite right here. I'll need to check further. So you have to start with security from the root of trust. Many, many different theatres for security. Tens of millions of malware created every day. The actors are increasing from states, cybercrime, hacktivists, and you think about the platforms that the Internet of Things can play out in, all the way from embedded technologies through consumer devices, through wearables, through transportation, through manufacturing. So this really is a complex environment. And so we want to connect these things, we want to manage them, we want to generate the data, we want to get the business value, but we also want to keep them completely secure. So how do you make sure that you drive this security? First of all, you have to realize these threats are there. You have to plan for them. You have to be meticulous in your knowledge. Secondly, you need to build up a culture that really looks at the security. We heard the presentations this morning about leaving the windows open in your house. You need to have a culture of being ready to engage security, and you need to have an architecture that enables you to protect all the way from the cloud service delivery, but all the way down into the endpoint. So when a device boots up or a sensor boots up, you know precisely what that thing is, and you know what you expect it to do. And you can do that by having very specific, secure capability in the silicon that you deploy your devices with. So, summarizing security, think about prevention. prevention is key, but you need to have an iterative process of understanding what threats are out there and responding to them. And then ultimately, if you do get attacked, you need to be able to remediate. So there's a very specific process there. And again, I'm not going to go through all the details. Probably at the back of the room, this is an eye chart. And you probably can't follow every kind of last pixel. But basically, you have to think about device, connection, cloud, security, and the event management around it. So we have very, very specific capabilities that builds that secure platform that all of the ecosystem can start to innovate around. So I showed the IoT demographic. So simplistically, Internet of Things for us needs to work in a very specific way. So you need to connect things and devices. Typically, those things will connect through a gateway. They may connect directly. The wearables that I wear connect directly into the cloud over a 3G, 4G network. But typically, they're going to connect through a gateway in industrial environments, in home environments. And the gateway can enable that first edge cloud management. We call it intelligence at the edge. I don't want to send everything to the cloud. The cloud is not centralized. The cloud is not the data center. If I'm a car and I'm driving along, I want to have some intelligence in the car. If I'm the 380 that flew me from London yesterday, the aeroplane has to have intelligence at the edge and know how to manage those systems, but then it can feed information back into the cloud if there's a specific need. You don't want to send all of the half a terabyte of data my aeroplane generated back into the cloud immediately. You want to manage that effectively in the gateway. And this, think of this as profound to the Internet of Things as client-server, and that transformation was to the mainframe as you go back 30 years ago. So connect things via gateways, then this comes into the cloud, turn data into insight. How are you going to manage that data? How are you going to effectively get insight from it? And then finally, as you go to the right of that chart, you need to figure out how to extract value from that data. How are you going to monetize? What's going to be the business model? We have a very, very active Internet of Things practice. I'll talk more about that in a few minutes. 90% of the projects that don't execute, it's not down to technology, it's not down to cost, it's down to business model. Is there a real business model that can be deployed? And then around this, you need end-to-end security. And it's not security just in the device, it's the security all the way through that process. And I've given you some thoughts on that already. So just a couple of things we're doing. Really interesting discussion we had earlier about startups. Now, one of the interesting things that I see as I kind of run around Europe, Middle East, and Africa, actually it's 104 countries, is there's this vibrant innovation community. There's all of the startups, entrepreneurs, kids at school, programming kind of wonderful solutions that could be deployed, and we need to link them together into corporates, governments, businesses. So this whole idea of putting them together in an innovation environment is profound, and I congratulate Dubai for really kind of grasping that and starting to see that. And Intel actually opened our first innovation lab here in Dubai. We've got that activity going in 2015. And the idea here is to provide capability for startups to deploy solutions. I'll give you a real simple example. I met with an R&D, head of R&D of a retailer recently, and they were looking at a very specific solution that was needed to push people more rapidly through their store. Actually, they were looking at effective management of nail varnish on hands, because people that are buying nail varnish tend to spend a lot of time varnishing their nails. And basically, really simple application that came up from a startup, which is you put your hand on a plain glass screen, there's an RFID tag on the nail varnish, and you can see your hand with that nail varnish immediately. So you can see a real, and then if you want to go further, you can look at that. Now, what was really interesting with that is that was innovation from a startup deployed by a brand, by the head of R&D in less than 60 days. So that's the pace of change that we're starting to see now. And we're really driving these innovators across Europe, Middle East, and Africa. I have 8 functioning now. I'm very proud to have one working here in Dubai. A couple of examples of deployments that I just wanted to kind of talk about. Everyone's been talking about the city of Barcelona. I think that's been a really good example of real-time usage of digital signs, advertising models to support that. I know we're starting to see significant momentum here, but the fact you get service information to the public, better travel experience, more efficient news, and critically to government, new source of revenue. So the business model there was pretty robust, which led to the rapid deployment. We're working with a company called Kingspan. Quite proud of this. Kingspan, with their HQ, have a net zero energy buildings. So basically they're using sun photovoltaic solutions. They have an internal mechanism, using our gateways of very efficiently managing the energy in their building, lights on, lights off, air conditioning, so on and so forth. And they're now generating one third more energy than they're consuming in that building. Net positive building, delivering energy back into the infrastructure, back into the city. Think about how profound that is in new business models. Clean tech, we heard a really interesting discussion on San Francisco this morning. This is an example from San Diego. Again, at the back of the room, you probably can't read that, but there's some very interesting integration of building solutions. What I like here is that all of the heating, ventilation, air conditioning solutions are being integrated into the network, so we're real-time managing the energy consumption across the buildings. So a great example of being deployed and driving energy savings, cost savings, reducing greenhouse gas. And finally, example, we've been doing some work with Siemens, which is basically looking at parking solutions. So that's a great example of the integration of different environments. You've got a traffic management system linking into a retail system, giving benefit. And this solution is being deployed in Berlin, and there'll be several more instances of deployment as we go through the year. And again, what's really interesting here is, you heard a lot about traffic management today, and the requirement to manage congestion. Actually, 30% of the traffic in most cities is people that have got where they need to go and then are just trying to find somewhere to park. It's even worse in Italy. It's 50% in Rome, where people are just driving around trying to figure out where to go next. And that's creating chaos in the urban environment, and it's very solvable by simple, practical usage of technology. So they're just a few examples of deployments that are happening now, delivering real business benefit. Technology is sound, but it's the business model that's enabling that to happen. So just in summary, I've talked about Internet of Things, things connecting into the cloud, generating data. That data can be analyzed. That data analysis provides real value in a business case. So that's the basic model. So data is the heart of it. We must protect this end-to-end system. We must protect a secure environment, manage things in a very private way. Collectively, we've got to harden these solutions, secure communications, manage that complexity. And we know how to do this, but we need to create cultures in the technology industry, but also in the deployment organizations to ensure that we protect our environments. Nobody can do this alone. I think that's been a great theme of the discussions today. This is about an ecosystem. And Intel is committed to helping to provide a platform for innovation. Then the innovation in the community will drive solutions. And we're very proud of our new Internet of Things Ignition Labs. Very privileged to have one here in Dubai, and looking forward to working with the community to deliver breakthrough solutions. So thanks ever so much for your attention, and look forward to working with you all to deploy the next generation of the Internet of Things. Thank you.
Rod, thanks very much. You look fit as a fiddle, Rob. I would stress that.
Heavyweight.
Figuratively. Now, we got a couple of minutes for questions. So who's got the first question for Rod? I've got thousands, but I'd much rather hear from you. Yes, please, sir. There's a gentleman towards the back of the room. Thank you.
My name is Rawat Badr. Nobody can deny the importance of IoTs and how can IoTs facilitate our life. Okay, but since you concentrate in security and how we secure the secure environment, how long IoTs can last in front of these security challenges and in front of these sometimes brutal attacks over the internet? What are the precautions and what are the actions against such attacks?
Yeah, it's a great question. First of all, I think you need to recognize the threat is there. You need to proactively engage in that discussion to understand it. So Intel's philosophy is that it needs to come from the ground up. So starting with every piece of technology that is deployed, that itself needs to be secure. Or if it can't be secure, it's a legacy piece of infrastructure, it needs to be connected into something that can really manage that security, and that could be the gateway. So if I know exactly what you're expected to do in the network, and you are doing that, if I know exactly what you will look like as you get up in the morning, and you look like that, then I can start to go through a series of tests to convince myself that you are an active member of the community and I should welcome you. So, you know, it's a much deeper discussion, but security is profound, but it starts from the bottoms up all the way through the environment. But, you know, and the key thing is there's a trade-off. There's business benefits that are going to come from the Internet of Things that are going to be massive and profound. Just the changes we talked about in health, for example, that are going to change your lives. So we want to get the benefits. We just have to make sure that we're managing and mitigating the risks in the right way. And then there's all kinds of discussions around governance as well. So, for example, if I said to you, I'm going to come in and turn your electricity off in your house and not tell you, you would say, I don't want you to do that. If your house was burning down, you might want me to do that. So it's then the governance around that. And we know how to do this. We just have to really all be aware of it. And we need to start with security built in from the ground up. Thank you. Great question.